Today's discussion is about the importance and simplification of speed time curves. The speed time curves are having fundamental importance in electrical traction. Speed time curve is nothing but a simple curve or a graph drawn between speed in kilometers per hour and time in seconds. On x-axis normally we call as abscissa, the time in seconds are taken, and on y-axis the speed in kilometers per hour, that is called ordinate, and plot the curve, we get the speed time curve. The speed time curve is shown in the figure. So in the figure O, A, B, C, D, E is called the speed time curve. The speed time curve is having good importance in electrical traction. The main advantages of speed time curves are the speed of the locomotive at any instant can be determined, or for any time interval we can find out the speed of the locomotive by using this speed time curve. In addition to that, the distance travelled by the train can also easily find out by using the speed time curve. The slope at any point on the curve gives the acceleration and retardation. Normally slope means we have to draw a horizontal line on the graph and measure the angle between the curve and the horizontal line. That angle will give the slope. That slope gives the acceleration value. Similarly, the propulsion of a train can also be found out by using the speed train curve, as well as the resistance to the motion of the train will be known. Speed time curve. It is a graph showing the variation of speed with respect to time. Gives speed at any instant after the start of the train. The slope of the curve gives acceleration at that particular point. Area under the curve gives the distance between the stops. Classification of speed time curve. The entire speed time curve O, A, B, C, D, E can be classified into 5 equal parts. O to A is called notching up period, or it is also called the rheostatic acceleration. A to B is called acceleration on speed curve, or it is also called speed curve running, and B to C is called free running period for the train, and C to D is called coasting retardation, and D to E is the braking retardation. So we will see one by one what is the meaning of this notching up period O to A. As the name itself indicates, notching, that means we have a starting resistance. The resistance is cut out slowly. The handle is moved from one notch to another notch, so the name is given as notching up period. It is O to A. The time period is 0 to T1. So during notching up period, the acceleration remains constant. The tractive effort developed by the train is also constant. Tractive effort means it is the force acting on the track by the driving wheel of the train. So normally we may have number of driving wheels. If we put together the tractive effort acting on the track by all the driving wheels, we get gross tractive effort. So the gross tractive effort is proportional to the combined torque developed by all the motors. Normally during notching up period, the current is maintained constant and the voltage across the motor is slowly increased. So the acceleration remains constant, the average torque produced by the motor remains constant and tractive effort is constant, but the current fluctuates between maximum and minimum limits. So this OA we get a straight line, a straight portion for the notching up period. Next, coming to A to B is called acceleration on speed curve. It is also called speed curve running. Normally during this period A to B, the current is slowly decreased and finally the current decreases and it reaches a steady value and almost a constant value. The voltage across the motor also remains constant, but due to decrease in current, the speed of the motor slowly increases during this period A to B. As the speed is increasing, the acceleration slowly decreases and finally the acceleration at point B will become 0. That is, we get the corresponding speed on the y-axis at which the acceleration will become 0. At this particular point B, the tractive effort developed by the motor is equal to the train resistance. So it is called as the acceleration on the speed curve. I will display the classification of speed time curves. Number 1 is notching up or rheostatic acceleration, that is O to A, already I have shown. Next, the acceleration on speed curve, that is A to B. It is also called the speed curve running. Next, B to C is called free running period of the train and coasting period, that is from C to D. Braking period D to E. That means the entire speed time curve can be divided into 5 major groups and one by one we can study in detail about all the groups. I told you the O to A is known as the rheostatic acceleration. Current is maintained constant by cutting the starting resistance. Voltage across the motor increases. Motor current fluctuates between maximum and minimum limits. So because of this, in the curve OA we get a straight portion, a constant line called rheostatic acceleration. Average torque developed is constant. Acceleration remains constant. That is, during rheostatic acceleration, the average torque developed by the motor is constant, the tractive effort is constant and acceleration remains constant. Current fluctuates between maximum and minimum limits. acceleration on speed curve, that is shown on the graph A to B, is called acceleration on speed curve or speed curve running. Voltage across the motor remains same. That means the voltage across the motor is constant and the current is decreased slowly. Effort exerted by the motor is more than the train resistance. Effort means that is the tractive effort, that is the force acting by the driving wheel on the track. So this tractive effort will be more than the train resistance during this period. Motor speed increases. So the speed of the motor gradually increases during A to B, that is in the speed time curve. Due to increase in speed, the acceleration decreases, finally it becomes 0. Acceleration decreases with increase in speed and finally becomes 0. The tractive effort developed by the motor becomes equal to the train resistance. Next part of the curve is called B to C, is called free running period. So normally the free running period will occur on leveled track only. Suppose if the track is having a slope or it is not a leveled one, we cannot get the free running of the train. During free running period, the train runs at maximum speed and constant speed will be maintained. The example for the free running period, that is only in the mainline service. Mainline service means, for example, we have a distance from Secunderabad to Vijayawada is called a mainline service. Normally the distance will be greater than 10 kilometer. The minimum distance maintained should be 10 kilometer. So this free running period will arise only on the mainline service. The train runs at a constant speed and constant power is drawn from the supply mains. Next, coming to coasting. The meaning of coasting means running the train without electrical power, it is called coasting. So that means during the coasting period, the power supply to the motor will be cut off. Normally the driver will feel that the destination is arriving shortly, so the power supply to the motor will be cut off during the coasting period. So even though the power supply is cut off, the train runs with certain speed because the train will have a momentum, that is mass into velocity. So because of its own momentum, the train runs slowly, but due to the presence of the train resistance, finally the speed will be totally reduced from C to D. The train resistance means it is the frictional force that is acting between the driving wheel and the track is called the train resistance, as well as the opposing wind that is acting on the locomotive. So these two are responsible for the train resistance. So due to the presence of this train resistance, the speed of the locomotive will be reduced during coasting period. So again I will discuss free running. The train runs with constant speed. The motor draws constant power. So that is due to the running of constant speed, constant power is drawn from the supply mains during the free running period. Coasting period, the power supply to the motor is cut off, train is allowed to run due to its own momentum. The speed of the train decreases due to train resistance. Next, coming to braking period. At the end of coasting, brakes are applied. So that means the train is slowly running and speed is completely reduced during the coasting period. So the driver, he will apply the brakes during that braking period, so that the train comes to a stop. The train comes to stop at the end of braking period. Next, coming to urban service. So normally the urban service is also called passenger services. Normally in metropolitan cities we can see the urban services or city services like Hyderabad and Madras. Thousands of people will be travelling in urban services. If you see the speed time curve for the urban service, you have acceleration, coasting and braking. So that means in the case of urban service, you have high acceleration and high retardation, that is braking retardation we have, but the free running period is absent for the urban service. So that means in the case of urban service, the distance between two stations will be around 1 kilometer. So because of the short distance, the train accelerates and immediately the driver will switch off the supply to the motor and brakes are applied. So in the case of urban or city services, the free running period for the train will be totally absent. We have higher acceleration and coasting retardation and braking retardation. Urban service, distance between two stops is small, 1 kilometer. So it is the minimum distance between the two stations, that is 1 kilometer for the city services. Normally the distance may vary, it may be greater than 1 kilometer also. High acceleration and retardation. So the train runs at very high speed, so automatically the acceleration and retardation will be very much higher. Fast speed schedule. Normally the urban services will run at very high speed, normally around 120 kilometers per hour. So due to the running at higher speed, the more number of trains can be run on the same route because of the heavy traffic we have to incur. A given traffic can be handled in less number of hours. So that means more trains should run on that route. So the given traffic can be easily handled within lesser time period. That means the route is heavily loaded and more trains have to run on that particular route. So fast speed schedule must be maintained for the urban or city services. What are the different values of acceleration and retardation for these urban or city services? Normally for urban service, the acceleration is 1.5 to 4 kilometers per hour per second and retardation is 3 to 4 kilometer per hour per second. Maximum speed is 120 kilometers per hour. So that is maximum speed of the train, and we have to maintain the required acceleration and retardation for the urban or city services. Distance between stops is 1 kilometer. No free running, small coasting period. So free running period will be totally absent because of smaller distance between the two stops, and the coasting period is comparatively small for the urban service. The coasting means running the train without power supply. That means the driver will switch off the power supply during the coasting period. Next, coming to suburban service. The main difference between urban and suburban service is only regarding the distance. The distance between two stations will be maintained 2 to 3.5 kilometers. So it is called as the suburban service. Normally the suburban services also fast speed schedule can be maintained. The distance between two stops is relatively longer. Here we are comparing the suburban service with urban service. When compared to urban service, the distance is relatively longer in the case of suburban service. High acceleration and retardation. So high speed can be maintained even for suburban service also, because it is also a passenger service and human beings, large number will be travelling every day from one place to another place by using suburban services. No free run and long coasting period. Free running will not present in the case of suburban service, because here also the distance between two stops is smaller, around 2 to 3.5 kilometer. So that means the train starts and accelerates, and immediately you have the coasting period. The driver switch off the supply and brakes will be applied immediately. So there is no question of free run for the train. Acceleration is 1.5 to 4 kilometer per hour per second. So this value of the acceleration must be maintained for the satisfactory running of suburban services. Suppose if you see the speed time curve for the suburban service, the time in seconds is taken on x-axis and the speed in kilometers per hour will be taken on y-axis. If you plot the graph for the suburban service, you have the acceleration and coasting and braking period. So here the acceleration is very much higher and retardation also will be higher. That means the coasting is relatively greater when compared to urban service. In the case of urban service, coasting is smaller, whereas in the case of suburban service, the coasting is a little bit longer and you have the braking period. So that means the brakes are applied and the train comes to a stop. This is the urban service. So the retardation is 3 to 4 kilometer per hour per second. So for urban service, we have to maintain the minimum retardation will be 3 to 4 kilometers per hour per second. Retardation means it is the negative acceleration maintained for the train. maximum speed is 120 km per hour. The train runs at a higher speed schedule, that is 120 km per hour should be maintained for the suburban service. Distance between stops is 2 to 3.5 km. So that is the minimum distance we should maintain for the suburban service. Next, coming to the mainline service. The mainline service is also called the long route service. Normally the example for the mainline service is from Secunderabad to Kazipet, or it may be from Secunderabad to Vijayawada, we call as the mainline service. So it is a long route service and the distance is very much larger, but the minimum distance should be maintained greater than 10 kilometers. Does not need high acceleration and retardation. So for the mainline service we need not require higher acceleration and higher retardation. So the acceleration and retardation period is a fraction of the total running period, that is, it is only a small fraction. Long free running and coasting periods. So free running period is very much longer in the case of the mainline service, because the distance is very much higher. The train runs at a constant speed for longer duration and constant power is drawn from the supply mains. Acceleration and braking periods are small. That means the coasting and braking period are comparatively smaller. Next, for mainline service, what is the minimum acceleration, retardation and highest speed should be maintained? There are certain limits. The driver has to follow those limits for running the train. Acceleration is 0.6 to 0.8 km per hour per second. Retardation is 1.5 km per hour per second. Maximum speed is 160 km per hour. Distance between stops is greater than 10 km. So for mainline service the speed is higher than the urban and suburban service, that is around 160 km per hour will be maintained under free running period. So normally the free running period will arise only on the level track. When the track is a sloped one, we cannot maintain the free running period. Next, maximum speed Vm. So what is the definition of the maximum speed? So normally this maximum speed is also called the crest speed. So it is the highest speed attained by the train during running. So that means in the mainline service normally the train will run at very much high speed and highest speed will be maintained for some distance. So it is called the maximum speed and it is denoted by Vm. So the highest speed attained by a train during run, it is also called crest speed. It is denoted by Vm. So in mathematical calculations, wherever the Vm arises, it indicates that it is the maximum speed attained by a train in kilometers per hour. So it is called peak speed, or it may also called as crest speed maintained by the train. Average speed. So normally we may call sometimes the train is running at average speed. So the average speed means it is the total distance travelled between two stations divided by the actual time of run for the train. So actual time of run means the stopping time should not be considered. Suppose for example the train is moving from Secunderabad to Vijayawada, it stops at in between 2 to 3 stations. So for calculation of average speed, the stopping time should not be considered, only the distance travelled between the two stations divided by only running time of the train. So average speed, it is the mean speed of the train from start to stop. It is denoted by VA. Average speed VA equal to distance between two stops in kilometer divided by the actual time of run, that is D by T, where T is called the actual time of run and D is the distance travelled between the two stations by a train. So it is denoted by VA. For all mathematical calculations, wherever VA arises, it indicates that it is the average speed, and VM comes, it is the maximum speed. Next, schedule speed. Sometimes we may call the train is running with schedule speed. Schedule speed means here the station stopping time must be considered. So that means schedule speed is equal to the total distance travelled by the train divided by the total time of run plus station stopping time. So it is called scheduled speed, denoted by VSCH. So schedule speed, it is denoted by V schedule. V schedule is equal to distance between two stops in kilometer divided by the actual time of run plus time for stop, that is the station stopping time. Therefore VSCH is equal to D divided by T plus TS. T is the actual time of run and TS is the station stopping time. The stopping time will be around sometimes 2 minutes or 3 minutes, depending upon the station. This time will be fixed. Factors affecting the schedule speed. So what are the important factors affecting the schedule speed? So number one is the acceleration alpha and retardation beta. Next will be the maximum speed Vm in kilometers per hour. Next will be the duration of stop. So these are the three important factors which affect the schedule speed. Acceleration and retardation. Suppose if the acceleration and retardation of a train is higher, then the total running time will be reduced. So that means train runs at a higher speed, so running time will be reduced. Whenever the total running time is reduced, the schedule speed will increase. So that is why when the acceleration alpha and retardation beta increases, the schedule speed will decrease. Next, maximum speed Vm in kilometer per hour. It is called crest speed. So when the maximum speed is higher, then the total running time will be reduced, because train runs at high speed, so it will reach the station in time, so running time will be reduced, so automatically the schedule speed will be greater. Next, duration of stop Ts. When the duration of stop, that means the station stopping time is higher, then automatically the scheduled speed will increase. Simplified speed time curves, trapezoidal speed time curve and quadrilateral speed time curve. So, trapezoidal speed time curve means, normally earlier we have seen the speed time curve for mainline service. So, for calculation purpose, the mainline service speed time curve can be simplified to a trapezoidal speed time curve. Similarly, quadrilateral speed time curve, that means the urban service and suburban service speed time curve, we have seen earlier that urban and suburban service can be simplified to a quadrilateral speed time curve for calculation purposes. So, here I am showing the speed time curve for the mainline service. This mainline service can be simplified into a trapezoidal speed time curve. So, the area in these two curves will be same, the acceleration and retardation will also be same, but in the case of trapezoidal curve, the acceleration remains same, that is O to A, and free running and coasting can be represented by means of AB, a line AB, that is the difference between the mainline service speed time curve and trapezoidal speed time curve. The speed time curve for urban service and suburban service can be best replaced by means of a quadrilateral speed time curve, because the calculations becomes simple by using the quadrilateral speed time curve for urban and suburban services. So, V1 is the maximum speed at the end of acceleration and V2 is the speed at the end of coasting. Next, trapezoidal speed time curve. So, time is taken on x axis in seconds and speed in kilometers per hour can be taken on y axis. You have a trapezoidal speed time curve. So, from O to A is called acceleration, it is denoted by alpha, and A to B is called free running period for the train, and B to C is called retardation, it is denoted by beta, and T1 is the time for acceleration in seconds, and T2 is the free running period in seconds, and T3 is the braking retardation, the time period, that is in seconds. So, normally for this trapezoidal speed time curve, now we will calculate what is the maximum speed Vm. So, d is the distance between two stops in kilometer, t is the total running time of the train in seconds, alpha is the acceleration in kilometer per hour per second, and beta is the retardation in kilometer per hour per second, and Vm, it is called crest speed or maximum speed in kilometer per hour. T1 is equal to time of acceleration denoted in seconds, and T2 is the time for free running period of the train, and T3 is the time of retardation in seconds, and T1 is equal to the maximum speed by acceleration Vm by alpha, and T3 is equal to Vm by beta, that is time for coasting retardation, and T2 is the time for free running, is equal to total capital T minus T1 plus T3. So, that means T1 is equal to maximum speed Vm divided by alpha gives T1, and similarly T2 is equal to total time, that is capital T, T1 plus T2 plus T3 equal to capital T minus T1 plus T3, we get free running period. Similarly, this retardation beta and T3 is the time for retardation, therefore we get the value T3 equal to Vm divided by beta. S is equal to area of triangle OABC. Area of triangle OAD plus area of triangle ABED plus area of triangle BEC. So that means we are finding the total area or the distance travelled by the train. So that means total distance, that is the area under the curve OABC. The distance can be easily found out. That means the distance travelled during OA and T1, that is the area of this particular triangle, plus the area of rectangle AB corresponds to time period T2, and the area of the triangle BC and T3 corresponding to this particular area of the third triangle. If we add these two areas, we get the total distance travelled by the train. Therefore, area, all these areas are half of Vm into T1 by 3600 plus Vm T2 by 3600 plus half of Vm T3 by 3600. Since it is a triangular area, half base into height, we get this particular formula we can arrive, and we are converting the seconds into hours and substituting for T1, T2 and T3 in the above equation. We get Vm square by 7200 alpha plus Vm by 3600 T minus Vm square by 3600 alpha minus Vm square by 3600 beta plus Vm square by 7200 beta. So you have to simplify this complete equation, and finally we get a quadratic equation, that is Vm square k minus Vmt plus 3600 s equal to 0. Suppose if you evaluate this quadratic equation, we get the crest speed or maximum speed Vm. Normally we have two routes. One route is T plus square root of T square minus 4k into 3600 s by 2k. So that means we have a positive root and negative root. Normally the positive sign gives higher value, so we consider only the negative sign. Today we studied about all the details of the speed time curves related to mainline service, urban and suburban service, and how to calculate the crest speed for the mainline service and how to derive the equations. So normally these services are very important in the case of electrical traction, and fundamental importance is given for these speed time curves.